Doesn't really matter whether you're in a hot spot or a cold spot. Organic farms produced about half the yield, 46% of the yield of the conventional farms. But because we've got variation, some fields were producing very high yields, even in the organic, some fields were very high yields, some fields were very low yields. We could look directly at the impact of intensification in terms of the yield on biodiversity. This is a graph for plants, and again, the details don't matter, but this is what you get. This is the relationship between plant species and the yield from a field for an organic field and for conventional fields, effectively. So what this shows is that with organic fields, you always get quite a lot more plants. But if you're driving the intensity of an organic field by putting lots of green manure on, for example, the biodiversity in those fields goes down. And actually, when you're getting reasonable yields from organic fields, the biodiversity makes no real difference whether or not your farm managed organically or conventionally. So that means if we're going to increase our yields by intensifying organically, we won't get a biodiversity gain from it, because it is the intensification that reduces the biodiversity, not the chemical use per se. It is because you've got a greater density of plants per unit area and so on. When you look at all the other groups, you get a very different pattern, and I'm not going to say anything because this is a bit daunting, but basically what is surprising is most of the time you get relatively flat lines, and it doesn't matter really whether you're conventional or organic. So this effectively says is if you reduce yields from, say, 10 tonnes per hectare to 5, you get a small gain in biodiversity, but you don't get a huge gain in biodiversity for all of these other groups. And that will come important in a minute. So summarising the data, these are our different groups, and this is the percentage increase that you get in organic fields versus conventional fields. It ranges from 60% more for plants, 40% in butterflies, to minus 34% in hoverflies. Hoverflies you get more in conventional land. So then let's answer the question, is land sparing or land sharing the best option? And what we've done, I've just put this graph up to show you that we've got some underlying models for it. What we have done is we've actually looked at a landscape and we have modelled it and said, what is, if you want to produce the same amount of yield and also maximise your biodiversity, is organic farming, where you're extensive throughout the landscape, or is conventional farming, where you're intensive in one part of the landscape and you have a nature reserve in another part of the landscape, which of those is better? And the result is that there is a critical threshold in our system, we're using our data, that if organic yields fall below 87.5% of conventional yields, it is more efficient, i.e. you get more biodiversity and more yield to farm intensively and have separate blocks of land where you farm the biodiversity. So actually, throughout a lot of parameter space, organic farming is not sustainable in the same way as conventional farming, because when you reduce yields, if you need the same amount of food, you have to land grab from somewhere else, and that land grabbing comes at an environmental cost because you're reducing the biodiversity on that extra land. So, land exclusively managed for wildlife has the most wildlife. Yield loss is considerable on organic land, and biodiversity gain isn't always large, although there is normally a biodiversity gain. So very often, the optimal way of maintaining yield and managing biodiversity is for conventional farming, I use that term advisedly, non-organic farming, plus wildlife reserves of some description. So that's the first question. The second question, we know from our data that you get a difference in biodiversity within a field, between the centre of the field, the edge of the field, the margin of the field. You get differences between fields. You get differences between crops, clearly. You get differences between farms in the landscape. You get differences between the landscapes in the region. Sorry, this picture seems to slip. Different groups respond differently in different ways to the landscape. And just as an example, what we found was that if you have neighbouring farms who are organic within that a 10 kilometres radius, if you have up to about 20% of farms that are organic, then on average you have 10% more biodiversity on your farm. So what this suggests is that any management of biodiversity ought to be done at a large scale, because the scale of management for mobile organisms is, the scale of conservation for mobile organisms is greater than the scale of management, which is the field or the farm. So you gain by getting neighbouring farmers to cooperate. And that's a kind of no-win, a no-cost gain in a way, rather than trying to get every farmer to behave independently. If you get groups of farmers behaving in the same way, then suddenly you get a big block of land that is doing the right thing, and then you get an increase in biodiversity. So just continuing that argument, we published a study a couple of years ago now. This is the distribution of organic farms in the UK. Red is where you get a lot of organic farms. Blue is where you get very few organic farms, and white is effectively where you get no organic farms. What you can see just by looking at this map is that organic farms are clustered in space. So you have a whole group of them on the west side of the country and relatively few on the east side of the country. And those organic farms are more likely to exist in low-intensity landscapes. And the reason for this is, in a low-intensity landscape, farmers can't farm productively because they've got valleys and they've got woods and they've got brick walls and they've got rock outcrops and so on. So they can't farm productively, so they've got to produce they can only produce a relatively small yield, so that they tend to want to go for a premium product and get higher prices, so they're more likely to go organic. But in such landscapes as well, you tend to have a much higher background biodiversity. If you're an organic farm in an intensive landscape, if you convert, because there's relatively little biodiversity in the landscape anyway, what happens when you convert is that you lose a huge amount of yield, and there isn't much of an environmental benefit because there isn't very much to kind of come in. So if you follow the logic of those, when you really get pressured for land use and you need to produce a lot of food, that kind of makes sense to do your land sparing, land sharing argument at a bigger scale than at a landscape. So in the UK, if we conserve most of our biodiversity in the West Country, that's not going to cost us a huge amount in terms of productivity, and we're going to gain a lot because there's a lot of biodiversity there anyway. Whereas on the east side of the country, which is our most productive side of the country, to gain biodiversity there would require a huge loss in yield. So it might make sense on a kind of regional basis to concentrate our biodiversity conservation on the east, on the west rather than on the east. And the logic of this continues as you go up each scale. So what is best to do depends on these factors here, and it makes sense as well, and I'm sure Harold will talk about it, it makes sense as well at the European scale. If Europe goes organic, what happens? We have to import more food that is land grabbed from conversion of semi-natural land in sub-Saharan Africa or something. And so if Europe drops its productivity, the end result is we won't eat less, we will just import more, and that comes at that biodiversity cost. Land sparing, if it's going to work, requires the spared land in your intensive landscape to be managed actively for wildlife. Now these can be reserves, but equally they could be strips of land that is properly farmed for wildlife, properly managed, properly monitored. And so it could be proper conservation margins. As we move towards a low carbon economy, we need the ecosystem services more and more and more and more, and so we have to manage biodiversity. And it makes sense, the scale of movement of a small wasp to go and nobble an aphid is about 300 meters. So it makes sense to have marginal strips, in some sense, to grow your crop of natural enemies or grow your crop of pollinators. So my vision for the future is an intensive landscape consisting of fields that are managed intensively, high yielding, and then strips of land throughout the farm where you have your natural enemy services. So it's not a matter of an intensive landscape is from here to infinity of wheat or barley or whatever, but you have to break it up. And then in other parts of the country where it's more appropriate, you have low productivity farms with high biodiversity conservation value. Okay, now this is the final thing I want to say. This is a paper that's recently been published, which shows the input-output efficiency measured in terms of carbon for a long-running experiment for organic and conventional farms. And what you find is that the efficiency output per unit input is about the same for conventional versus organic farms. The only difference is that for an organic farm, you need twice as much land to produce the same output. You put half as much in per unit area, but you put the same amount in over the total unit area. But when you can compare that with no-till systems or low-input systems, the efficiency goes up. So whichever way that we look at it, conventional agriculture has got to green and can green in a way that will both conserve yields, make it more efficient, make it more environmental friendly, but also conserve biodiversity. So, summary, extensification land sharing is not a good strategy for maintaining biodiversity and food, and we can do it properly in a scientific way. Land sparing makes more sense. Future farming is going to be green. And then final point, Michael kept on saying we need to tailor our prescriptions to the landscape. Couldn't agree more. We need to get farmers to cooperate. I couldn't agree more. And we need to monitor how farmers are doing at providing ecosystem services, and we've got to develop the tools to help a farmer know that he's doing the right thing. Okay, I think I'll